Good day. So this is now lesson 8A, third part, and I will now discuss to you the lesson on gradients. Good day. I will now discuss to you the continuation of our lesson on lesson 8A, which is all about directional derivatives and gradients. Specifically, I will discuss to you the properties of gradients. Let's have the properties of the gradient. Having this theorem, it says here, let f be a function of either two variables or three variables, and let p denote the point p with coordinates x sub 0, y sub 0, or p with coordinates x sub 0, y sub 0, z sub 0, respectively. Assume that f is differentiable at the given point p, letter A. If del f or gradient f is equal to 0 at point p, then all directional derivatives of f at point P are 0. Letter B, if del f or gradient f is not equal to 0 at point P, then among all possible directional derivatives of f at point P, the derivative in the direction of del f at point P has the largest value. The value of this largest directional derivative is you have the magnitude of del f at point P. Letter C, if del f or gradient f is not equal to 0 at point P, then among all possible directional derivatives of f at point P, the derivative in that direction opposite to that of del f at point P has the smallest value. The value of this smallest directional derivative is negative of the magnitude of del f at point P. Let us have this first example. It says here, find a unit vector in the direction in which f increases most rapidly at point P, and find the rate of change of f at point P in that direction, so also as the maximum value of the directional derivative at point P. So the given function is f of xy is equal to the square root of x squared plus y squared with the given point P with coordinates 4, 3. So in this problem, we're going to find the unit vector in the direction in which f increases most rapidly at P. So this is denoted by, we have the unit vector u equals del f evaluated at xy over the magnitude of del f evaluated at xy, where del f evaluated at xy is equal to partial derivative of the given function with respect to xi evaluated at xy plus the partial derivative of the given function with respect to y evaluated at xy times j. So to find the unit vector now, we'll start with finding the gradient f or del f of xy. So with that, we now have to find the two partial derivative of the given function with respect to x, then with respect to y, then evaluate it at the given point 4, 3. So we have here the given function f of xy is equal to the square root of x squared plus y squared. So taking now the partial derivative of the given function with respect to x, so we have the notation f sub x of xy is equal to the derivative of this given function. So let's recall the formula of the derivative of a radical. So we have here now, in the numerator is a derivative of u with respect to x all over 2 times the square root of u. So with that, let's get now the derivative of the given u here, which is the radicand with respect to x. So taking into consideration that y is constant, so the derivative of y will be 0. So with that, we now have this as 2x all over, you have in the denominator 2 times the square root of u. U here is x squared plus y squared. So let's simplify. So the answer here is x all over square root of x squared plus y squared. Then let us now evaluate the value of the partial derivative of the given function with respect to x at 4, 3. So with that, we now have this as x is 4 all over the square root of x is 4 again, then square that, then plus y equals 3, square that. So the answer is 4 over, this is 16 plus 9, 25. Square root of 25 is 5. So that's the value of the partial derivative of the given function with respect to x. Then let's get the partial derivative of the given function with respect to y, denoted as f sub y of xy. So this is our function, and using this formula, so this time x is considered as constant. So taking the derivative of your u, which is the radicand, so derivative of x squared is 0, derivative of y squared is 2y, all over, we have the denominator here 2 times the square root of x squared plus y squared. So simplifying, you can now cancel 2. The answer here now is y over the square root of x squared plus y squared. So from here, we can now define what is f sub y evaluated at the given point 4, 3. So here we have in the numerator is y, so that's equal to 3 all over the square root of x squared is 4 squared, quantity 4 squared plus quantity 3 squared. So the answer here is 3 over, again, this is square root of 25. So that is square root of 25 is 5. So with that, we can now write our del f. Del f now is equal to, using this formula, so evaluated at 4, 3, because this is xy, so our point is 4, 3 is equal to f sub x of 4, 3, that is equal to 4 over 5. Then you have I, then plus f sub y is 3 over 5, evaluated at 4, 3, then you have j. With that, we can now find the unit vector. So for that unit vector now, we have the formula del f of evaluated at 4, 3 all over the magnitude of del f evaluated at 4, 3. So your del f evaluated at 4, 3 is 4 over 5i plus 3 over 5j. Then all over the magnitude of del f evaluated at 4, 3. So that means you have to take now the square root of 4 over 5 quantity squared. So we will eliminate the I and j. So that will just be in bracket form. This is also 4 over 5, 3 over 5. So let's have that 3 over 5 squared. So in this case, the answer here is 16 over 25 plus 9 over 25. So 25 over 25 is equal to 1. Square root of 1 equals 1. So therefore, the unit vector will now just be 4 over 5i plus 3 over 5j. So this is our answer for the unit vector u. And to find the rate of change of f at point P in that direction, so also as the maximum value of the directional derivative of, of the function f at point P. So this is just simply the magnitude of del f evaluated at 4, 3. So the answer is right here. And this is now quantity 4 over 5 squared plus quantity 3 over 5 squared. So 16 over 25 plus 9 over 25, that's 25 over 25 is equal to 1. I have here the answer for example number 1. So for the maximum value of the directional derivative, it is equal to 1. And the unit vector in this direction is, we have 4 over 5i plus 3 over 5j. So my answer is correct as shown from the previous slide.